Precalc, Chapter 4, Section 4, we're going to evaluate trig functions of any angle, and we're going to use reference angles to help us find our trig function. So this chart below here, you should be able to complete this. So if you want to pause the video and see if you can create or fill in all of these blanks. And so go ahead and try that and see how quickly you can do that. If you need to make triangles, you can do that, or use, do not use your unit circle, but if you need to create a unit circle, or think about the unit circle, you can do that. So if you go through these, the radian measures, so 0 radians, at 30 we're at pi 6, at 45 we're at pi fourths, 60 we're at pi thirds, 90 we are at pi halves, and we're jumping to 180, which is pi, and 270, which is 3 pi halves. And so you can think about the spots in the unit circle we're actually looking at. We're looking at the 0, the 30, the 45, the 60, the 90, 180, and 270 is all we're looking at here. So the sine, now hopefully recall that sine are our y values in the unit circle. So at 0 degrees, we're at 0. At 30, we're at 1/2. At 45, we're at root 2 over 2. At 60, we're at root 3 over 2. At 90, we're at 1. 180, we're at 0. And at 270, we're at -1, going down. Cosine, we're at 1 at 0 degrees. At 30, we're at root 3 over 2. And then we're at square root of 2 over 2. 1/2. At 90, we're at 0. At 180, we're at -1. 270, we're at 0. So you can see some similarities between sine and cosine, how they're the same values at different spots. And that's because that 30-60 triangle gets rotated around or flipped around the unit circle. The tangent is always found, actually the cosine here is x. The tangent is always found by doing the y over x, sine over cosine. So you can kind of see we're just dividing these. So 0 over 1 is 0. 1/2 divided by root 3 over 2. So when you do that math, 1/2 divided by root 3 over 2 is like multiplying by 2 over root 3. These reduce out, so you get 1 over root 3. And if you rationalize that, you get root 3 over 3. 45 is 1. And then we get root 3 for 60. Undefined for 90. 0 at 180. And undefined at 270. So this is trying to show you how well do you know these values. These are ones you should be familiar with, comfortable with. So if I said sine of 60, you should just know it's root 3 over 2 pretty quick. So we've learned the unit circle where the radius is 1. What if r is not equal to 1? So we don't have the unit circle. So given a point xy that's on the terminal side of our theta, our angle, and r has a distance of x squared plus y squared square rooted. So it's really like the Pythagorean theorem. So in the drawing here, we have our theta measure here. We have our point up here as x, y. So then we have some triangle, right triangle here. That's a distance of x and a distance of y. And so if you do the Pythagorean theorem, you find our r value here. And so then our sine of theta is just going to be our y over r. Cosine of theta is x over r. Tangent of theta is y over x. Cosecant is the reciprocal, so it's going to be r over y. Secant theta is r over x, and then cotangent theta is x over y. And so we're using this right triangle still. Even though we're finding theta, we're actually using this right triangle to help us find our trig functions. So for all these trig values, I'm really trying to get a picture here of a right triangle where I can just do my SOHCAHTOA to help me find my values. And that's really what's called the reference angle. The acute angle is theta prime. So back here, this acute angle that we're actually using to find the measures, this is theta prime. This angle here is called the reference angle. So this reference angle is actually the value that helps us find the 6 trig functions. Even though we're evaluating theta, we're using theta prime, our reference angle, to actually find the trig functions. And so a reference angle is the acute angle of theta prime formed by the terminal side and the closest measure to the horizontal axis. So if we're trying to find our 6 trig functions, or actually we'll just do sine, cosine, tangent for -5, -12, make a drawing. I mean, really, it comes down to drawing our triangle. So where is -5, -12? So -5 is over here. -12 is way down here. So we have this point. So here would be our R value. And so if I create my right triangle, I'm going to go back, vertical back to the x-axis, and then horizontal to the origin. So I have my x value, my y value, which my x value is -5, my y value is -12. If I want to find my hypotenuse here, I'm going to do the Pythagorean theorem. So it's going to be 25, which is 5 squared. 12 squared is 144. This is going to be r squared. So if I add those, I get 169 equals r squared. So r is going to be 13. And I'm not doing the positive and negative, so it's a distance. It's only the positive values. I know this distance here is 13. So now if I want to find my sine of my angle, theta, and here's our angle we're looking at here, it's the opposite, -12, over our hypotenuse 13. Cosine of theta is our adjacent, which is -5 over our hypotenuse 13. And tangent of theta is our opposite, which is -12 over our adjacent -5, which is 12 over 5. And so you can go back to that saying where we say all students take calc, and since where the point is in this quadrant, the tangent's positive, the other ones are going to be negative. So you get the -5/13, -12/13, and +12/5. So then that's how you'd find the trig functions. And you could find all 6 by just doing reciprocals, but we're going to call it good with those 3. So I'm going to have you do this one for your homework video problem. And actually take the sine of theta is equal to 4 or 5. So think about what sine represents and what those numbers mean. And then to know that you're in the second quadrant. So try making a drawing for that. And then state what the cosine of theta would be and what would the tangent of theta be using this information. So give that a shot. 2 more examples. Cosine of 4 pi thirds. Now I'm given my angle. So I still want to create my drawing. But I need to figure out where 4 pi thirds is. So we have pi thirds, 2 pi thirds, 3 pi thirds, 4 pi thirds down here. So 4 pi thirds will still make my triangle. So I'm going to draw vertical back to the x-axis, then my horizontal. So I have my x value, my y value, and I have this reference angle. So the entire angle is 4 pi thirds. So I did like 4 pi thirds minus pi, because pi is this portion. So minus pi, and I end up at pi thirds. So I know that this reference angle is pi thirds. So now I'm going to look at all of my right triangle for pi thirds. So pi thirds is 60 degrees. So now I'm looking at a triangle here where I know this is 60, this is right, this is 30. So I should know my measures. I should know that this is my 1/2, my short side. This is √3/2, and this is going to be 1. And those ratios are true of the side. So even if I had this side be 1, then this one here would be double this, so it would be √3, and this would be 2. So the proportion of these will always stay the same because it will be similar triangles. So the cosine of 4 pi thirds is going to be just the x value here, which would actually be the -1/2, because we're in the third quadrant, and it's all students take calc, so cosine's got to be negative. The negative is the x value here. If I wanted to find the sine of this value, I can find that pretty quick here. The sine is just be -√3/2, and then I know the tangent of that value is found by dividing these two. So the opposite, √3/2 divided by 1/2, which ends up being just √3. And you can show that work if need be. You see the √3/2 divided by, which means multiplied by the reciprocal, those reduce out, I get √3. And so those are trig functions for that angle cosine 4 pi thirds. Last one, tangent of -210. So we want to find this value. We'll just find this one trig value. So -210, it means we're going the opposite direction. So we're going -210 degrees this way. So I know that if I go negative degrees, this is past 180, but before 270. So it's going to be up here. So I can do -210, and then I'm going to figure out if I add 180 to that, and it's really doing like 210 minus 180 is 30. That's what's going to be left over in this portion. So I know I have a reference angle of 30 degrees. So my triangle here, I have a 30, 60, 90. And so I have my 1/2 root 3 over 2, my opposite adjacent. So to find the tangent, it's the 1/2 divided by or multiplied by the reciprocal. And so this is going to give me the root 3 over 3 for this value. And then the last thing you need to check is our signs. All students take calc, and so in this quadrant, sine is positive, which means tangent has to be a negative, the negative ratio. And if you know why that occurs, we're really doing a negative x value divided by, or a positive y value. So it's a positive y value divided by a negative x value, which gives us a negative tangent value. So this would be the ratio for tangent negative 210. So even though we may not know 210 what that's talking about, we can use our reference angle of 30 to actually find the tangent, and then use our all students take calc to double check our sine. So that's it for 4.4, quick video. So call it good. Have a good night.